now we're going to move on to functions. So we've always been working with functions, but now you get to see in depth what a function actually is and what it consists of. So, to start with our solving, as you can see, it says your friend is playing a board game. He's on the space drawn in the diagram at the right. He rolled a 3 to get that space. Where could he start it? Explain your reason. So you see that he's on space 8. Now, if he rolled a 3 to get there, where did he start? So, you can see that there are many places where he could have started. So, this 3 that he rolled could belong to many other, more than just one space. So he could start it at space 4, he could have started on a different space other than that. He could have started possibly on space 11. So you see that there are many possibilities. So how this relates to functions is you see on your notes that there is, for every input, there's an output. So let us start off with problem 1. So it says match the domain to range. So if you look at your notes, domain is all the possible x values and the range is all your possible y values. So we have a set of 2.5, 0, 2.5, and then we have 4 and 6.5. So I'm going to label my x here, my domain, my y right here. Now you can put this in any order. I prefer to put it in the order it's listed so I don't get confused. But to show you, -2 belongs to 0.5, so I draw an arrow there. 0 belongs to 2.5, so I go down there, and 4 belongs to 6.5. So, why don't you try the got it, where it says match the domain to the range for 6, 5, 4, 3, and 6, 4. You can see what makes this a function is that one x is going to one y. There aren't two x values that are going to the same y value. So we'll see this in other examples. So why don't we move on to problem 2. So it's asking you, is this relation a function? So first off, let's look at what relation is. It's a pairing of numbers, such as coordinates. And see if something's a function, like you see in your notes, is doing a vertical line test. So you draw a straight vertical line and see if a function, such as this one, let's look at a parabola. Draw a vertical line, and does it only hit in one spot? Yes, it does. So, if the vertical line only hits in one spot of the function, then this is a function. So, to start off with problem 2, we have the coordinate points, -4, 2, -3, 1, and 4, -2. So you could do this one of two ways. I prefer using a table because it's a little bit clearer to see. So I have my domain and my range. This is domain, this is range. Alright, so our domain is the x values. Let's see right here. So I'm going to write it down. -4, -3, and -4s are in twice, so I'll keep it right there. And our range is our y values, 2, 1, -2. So why don't we write down and draw our lines across. So -4 belongs to 2, 3 belongs to 1, and 4 belongs to -2. And -4 belongs to -2. Now, you can see here that you have two y values belonging to the same one x value. So therefore, this is not a function, because you can see if you graph it, you have -4, 2 here, you have 3 -3, 1, and then you have -4, -2. When you do a vertical line test, you can see that this hits in 2 spots. So there are 2 y values belonging to 1 x value. So therefore, this is not a function. So why don't we try the got it? And then we're doing the same thing. We want to know if this relation is a function. So use the vertical line test. All right. So for problem 3, you have the function w of x equals 250x. Now, this is in function notation, as you see in your notes. It's w of x. That means in terms of x. So it's the number of words, w of x. So this is a number of words you can read in x minutes. So this belongs to minutes. So how many words can you read in 8 minutes? So we can see here if w of x equals 250x, and we're looking for x equals 8 minutes, you can write this as we're valuing w of 8 equals 250 times 8. Because you can see, whatever number you plug in for x here, it's also plugged in right there. So this number here, whatever this number is, I'm going to put that in for x. For every x I see, I'm going to plug in 8. So w of 8 is the same as 250 times 8 because this is because x equals 8. So in the same problem for the got it, how many words can you read in 6 minutes? So why don't you try that? So for the last 2 problems, they're more or less the same. So for problem 4, you want to know the domain of f of x. The domain of this function, that means all possible x values, are 1, 2, 3, and 4. So this is our domain. This is all our possible x values. So, and you want to calculate the range. So those are all possible y values. So you do is, like we did in the other example, for every x you see, you plug in 1. So it's going to be -1.5 times 1 plus 4, -1.5 times 2 plus 4, and -1.5 times 3 plus 4. And why don't you try the last one? It's going to be, remember, for every x we see, we're going to plug in 4 plus 4. So then we get 2.5, 1, and then you can calculate the rest on your own. So, to follow the same process, why don't you try that for the got it? The domain of g of x, which is g of x equals 4.5 minus 12. The domain is 1, 3, 5, and 7. So why don't you try to do the same thing we did right here. So, for the last problem, problem 5, problem 5 just is a word problem. It's the same as problem 4. You have 3 quarts of paint. Quart of paint covers 100 feet squared. If the function is a of q equals 100q, and you have 3 quarts, what's the domain and range? Now, if you have at most 3 quarts, that means that you can range from 0 to 3. 0, 1, 2, and 3 quarts. This is your domain. Your range to calculate is, so we're going to do, for every q we see, we're going to plug in 0. For every q we see here, we're going to plug in 1. 100 times 2. And then, what's the last one? For every q you see, you're going to plug that in, right? So that's 0, 100, 200, and 300. So, why don't you try the got it? You want to know if you have 7 quarts of paint, what's the domain and range using the same problem in the same process.